All right, we're going to try and run through some of the raster operations that we failed to review because I was absent. Here we have in ArcGIS Pro a new project, and it has nothing in it but a raster data set of a few craters on Mars. This is a DEM, a digital elevation model. If we zoom in really close, we can see, not very well, the pixels. And if you click on each pixel, you can see the value in that pixel. Now, this being Mars, I have no idea what they're using for above and below sea level. These are probably meters above something, but I don't know what. So the numbers in this raster are elevations. And when you color those elevations by different shades of gray, you get a nice image of the landscape of Mars. So let's do some operations with this. We're going to start with the surface operations, which are very straightforward. Surface operations are ones which work in the plane of the image. So they don't require multiple layers. They're just pixels looking at their neighboring pixels and making some kind of computation. So let's start by going to the analysis banner and the toolbox and the spatial analyst tools. And under spatial analyst tools, we'll go to the surface tool set. And let's start with slope, which is a nice easy one. Slope will, for each pixel, look at all the pixels around it, decide which one has the greatest difference in elevation, and record that difference as either a degree, or like a degree from 0 to 90, or a percent slope. So we just run the tool. It's quite straightforward. Input is Mars. Output is anything you want it to be. I will take my answer in degrees. I could have it in percent rise. And we'll just run it. And for those of you who are used to ArcMap, you'll see that the symbology that they choose for slope is much more attractive now. And you know, the darker colors here indicate the greatest slope. This very dark brown is, between 45 and 90 degrees. So if we go right here to this little riverbed, we can see that it has, extremely steep sides, like almost cliffs on the side. It's a nice symbology. I like it. And so the flat areas are the lightest color here. That's slope. It's very easy. We could symbolize. We could re-symbolize this if we wanted to. We could change the number of classifications. We could change the color scheme. We could divide it up into 3 classes, for example, flat, slopey, and steep. But I won't do that because I do like this symbology so much. I'm just going to leave it. All right. Let's run another surface geoprocessing tool. Let's try aspect. What the aspect tool does is basically the same thing as the slope tool. For each pixel, it looks around and it says which neighbor is my steepest drop-off. And then what the aspect tool tells you is that neighbor, is that slopiness facing north, south, east, or west, or northeast or southeast, etc. So we can run the aspect tool. The input raster is Mars. We don't care what the output is called. This planar, by the way, I think I've mentioned this before. You have a choice always between planar and geodesic. Geodesic would take into account the curvature of the surface of the Earth, or in this case, the surface of Mars. It takes a lot longer and is usually not necessary, so I would stick with planar. If we run the aspect tool, the aspect symbology is not quite so nice. Basically, the output of aspect is in degrees, where 0 and 360 are both north. So anything you see here that is red is north facing, whether it's got a very low value or a very high value, and then the color wheel sort of works around the circle so that south is the brilliant blue stuff. Why might you want to know this? Well, aspect is really good for determining insolation. Where does the sun shine, say, for example, on these craters? So if this were in the Martian northern hemisphere and it was noon, you would figure that all the south-facing slopes were sunny and all of the red north-facing slopes would be in some sort of shadow. Like if you look at this little crater right here, the sun would be illuminating the brilliant blue spot, and this would be in shadow, this red, presumably. All right, that's aspect. And as I said, the symbology is not quite so nice with aspect, but it's okay. Let's run the Hillshade tool. Now, Hillshade is really not that analytic as tools go. It's more of a visual effect. It will model shadows, though it will pretend there is light shining on the landscape and make some representation of sort of how the shadows would fall. I'll show it to you because it's a nice effect, but it doesn't have too much analytic value. So again, it just takes Mars as its input. And you have an option here to set where do you want the sun to be in the sky. The defaults are where we expect the sun to be, like maybe morning light in the northern hemisphere. You could change that, but if you change it, you will get that weird effect that you get with a lot of other planets and craters where you reverse the 3D effect where the craters look like bumps and the mountains look like valleys because the sun is not where you expect it to be. If we click Model Shadows, it will give us a nice effect, and the Z factor would be if you wanted to really exaggerate things. You could give it a Z factor, but I don't. So we'll just run it like this. Hillshade is like a fake way of showing 3D. You see on its default symbology, it kind of has a little 3D effect. One thing that I like to do, and anyone who's had my class before has probably seen me do this, if you change the symbology on this to one that is a little bit darker, like if we change the stretch from min-max to maybe standard deviation so that you really get more contrast. Number one, that looks great. But what you can also do is up here on the Appearance tab, you can make it semi-transparent. So what it does is it gives a 3D look to the stuff that's underneath it. Like that's the slope layer, but if we turn off the slope, we could see the craters with a little bit of a 3D effect, which is kind of cool. Like now the riverbeds really look deep. If you have doubt that it's actually doing anything, watch what happens when I turn it off. Like it looks suddenly really flat again. So that's an example of what Hillshade can do for you. It really sort of brings to life the third dimension in these images. Okay. There's one more tool I'd like to run from this surface toolbox, and that is the Viewshed. But Viewshed requires something that we don't have yet. In order to run the Viewshed tool, which will, the idea is you could, plop a little guy on the edge of one of these craters and the Viewshed tool will show you what he can see. We don't have an observer. We need a little guy to be our observer. So I noticed there's this observer points tool. I'm not going to use that. Identify as well. Nah, okay. Instead, we're going to go through the exercise of creating a point shapefile with the editor because I also think that is something that we forgot to review in our last class. So we're going to create a point shapefile that contains an observer. We need to start with a new empty shapefile, and we get that by going to the catalog, finding a location that we want to store that new little guy, right-clicking and go to New Feature Class. Now, this is different. We used to say New Shapefile. They're trying to get rid of shapefiles. So New Feature Class. Oh, and it shows up over here. We give it a name, like we'll call it our observer. And the type for us right now is going to be points. We have a choice of M values and Z values. Z values are good because they can store 3D information, and we're working with elevation. So we may actually want Z values at some point. M values are for routes, and I don't think on Mars we're going to be doing any route data with points. So we can click next and just flip through these. You could add fields at this point. You could give it a special spatial reference at this point. I wonder if that's worth doing. I don't know if we'd have the ability to copy this Mars. Let me see if it's in here. Projection. No. I'm a little nervous about that. I'm just gonna let it go for now, I guess. Tolerance, we don't need that. Resolution, I'm not gonna worry about that. Oh, you know, this is all a bunch of stuff we don't really need. Okay. The whole point is we want to, in our table of contents, when we look at our map, have an empty, and it's gone. Oh, maybe we have to add it. Let's add data, and it should be called, put it in our databases, and I called it observer. Okay, here it is. So now I have an empty point shapefile called observer. I want to plot an observer point. So to do that, we need to go to the edit menu. And here, as far as I've been able to tell, there's no longer a start and stop editing like there used to be. If you're highlighted on this layer, this is the layer that we assume you're editing, and you can go straight to create features. Click on observer, and your choices are create a point feature, create a point at the end of the line, which we don't want, and create points along a line, which we don't want. We just want a point feature. And so let's see, we're going to be the little Mars Explorer. And we're going to put you, first we're going to put you on the rim of a crater. And then we're going to hide you way down inside one of these craters. Right there. Okay, so we have 2 points, and we can try the viewshed from each of them. Having created points that we're happy with, we can go back to that edit toolbar here and save our edits. And now, even though they're a little hard to see, we have 2 points. I'm just going to change the color so that they're a little easier to see. Okay. And I'm also going to clear selected features because I don't want to have one selected that I don't know or care about. Okay, so now we have some observers. Let's run the Viewshed tool from each of those observers. Now, just to remind you, if we use the selector and we do select one of these points, the tool will be run with only the selected points as input. So we could run the tool one time with this guy selected, and then we could come back and select this guy and run the tool with him, and we will get different results. So let's go take a look. Let's do that. Take a look. I'm going to use Viewshed 1. They're fairly comparable. The output is about the same. As we discovered in the Institute this year, Viewshed 2 has a lot more options. Like you could make your observer a certain height above its location, like if it were a tall person or an observation tower or something. But we're just going to use Viewshed 1 because it's simple. To run a Viewshed, you still need a raster. You need, like the Mars elevation raster. And then you need the point that represents your observer. We need an output spot, and everything else should be fine. And if we run this, we get as output a raster of places you can see and places you can't see, basically. All right, so only that orange stuff can be seen by this observer here. Really, I would have expected he could see more. There must be, I bet if we zoomed in here, I bet there's a ridge like southeast of him that's blocking this part of the landscape. Let's see if we zoom in just a little, if we can tell. Yeah, it's a little hard to tell. But he does seem to have some landscape features around him that may be blocking off parts of the landscape. So those are the areas that are available to be seen by the rover if it were in this location. And then we could switch our selection. And we could run the very same tool, although I'm going to give it a different output here. And we can see what can be seen by that little guy sunk down inside the crater. And boy, you know, he can't see much. Oh, well, of course, they're both orange. Let's change the color so we can see the difference. Give him green or something. All right. So, clear features, clear selected features. So now we can see that that guy sunk down in the crater can only see the crater around him, whereas this guy has a view and he can see a large portion of the landscape. All right, that's it for surface operations right now.